All right, here's lesson 2, adding polynomials. So one thing we got to do is identify like terms. So like terms are the same shape. So in the last lesson we talked about x squareds, positive and negative x squareds as being big rectangles. And then we talked about positive and negative x's as being rectangles, and then positive and negative ones as being little squares. The last one should be negative 1. Okay, so basically you're looking through and saying what have the same shape. So in this first one, 13x squareds, x squared, and 2x squared. Those are all like terms. They have the same exponent, the same shape. In the next row, highlighted in yellow, what has the same shape? Well, the 2 is a constant. So is there any other constants? Nope, 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 and nope. All right, we got negative 9x. Okay, this is x squared. This is just x, and this is just x. So the stuff that are the same are the things that have x's as the variable, the same exponent. All right, and the last one, we've got x squared, a number, x, and x squared. So x squareds appear to be the only things that are in common. So when you're combining like terms, we have things called zero pairs. Okay, zero pairs, things that add up to 0. So if I have positive 3 and I subtract 3, I get 0. If I have negative 7 and positive 7, still 0. 1204 and negative 1204, still 0. So if it's the same thing, but one's positive, one's negative, it will, in fact, add up to 0. The same thing happens with algebra tiles or polynomials. Okay, so this is a positive 1, and we're adding a negative 1. This will still equal 0. A negative x and a positive x, 0. And a negative x squared and a positive x squared, 0. So we can kind of simplify these algebra tiles example by looking for zero pairs. So for example, this tile here and this tile here, that is a 0 pair. So you can cross those out. They will add up to 0, so they are irrelevant. See you later. We can also look at this negative x and a positive x. That's also a 0 pair, so we can cancel those out. Is there anything else? Yeah, we have a positive x and a negative x. So those two are also a 0 pair. So what are we left with? So we're left with these two guys hanging out here. We're left with this big x squared, and we're left with 2x squared. So if we simplify this, we are left with x squared, positive 2x, and positive 2. That's the simplified version. Okay, in the next example, find some 0 pairs. So pause the video, get out your marker or whatever you're using, and cross it out and see how you do. Okay, well right away here I see a 0 pair with the negative x squared and the positive x squared. I also see 0 pairs here, a 0 pair there, a 0 pair with those two, and a 0 pair with those two. Nothing else is a 0 pair, so we're left with writing what we have remaining. So we've got a negative x squared remaining, that's this guy, and we've got negative 2x, and we've got positive 3. And that's our simplified expression. The last one's a little tricky. Again, pause the video, cross out what you think are 0 pairs, and see what you have remaining. So right away, there's a 0 pair, there's a 0 pair, and there's a 0 pair. There's a 0 pair there. I can also cross out this one and that one. I can cross out those two, and I can cross out 2 of these with 2 of those. So let's figure out what we got left. There's 2 there. I've got an x squared. And do I have any... Oh, and I also got that guy. Okay. Anything else? No. So what I'm left with is x squared and positive 3. Okay, here's an expression. Before you write the number of terms, so you'd be tempted to go like, okay, well, there's negative x squareds, there's positive x squareds, there's negative x's, positive ones, and positive 2. So there might be 6 terms. Well, that's not the case, okay? Shapes dictate the number of terms. So how many different shapes do you have there? And there's 3 different shapes, but let's simplify it first and see what we're left with. So a 0 pair, a 0 pair, a 0 pair, and a 0 pair. So what we're left with is, and a 0 pair. So we're left with 2x squared minus x plus 1. So there are 3 terms. That means it's a trinomial. The degree is 2. The coefficient is 2 and negative 1. And the constant is positive 1. To simplify 2 or more polynomials together, collect like terms. For algebra tiles, this means pairing up the tiles with the same size and shape. For simplifying polynomial expressions, the like terms have the same variables and degree. Simplify the following polynomial expression by collecting like terms. All right. So symbolically, we have 4x minus 3x squared plus 2x plus 4x squared. So let's first slash and dash our like terms. So we've got 1, 2, 3 of those, and 1, 2, and 3 of those. I think that's about it. That's all we can slash out. So what I'm actually going to do on the left here is I'm going to group the same stuff first. Oops, that's not an eraser. There it is. All right, so let's just group our negative 3x squared and our positive 4x squareds. And then we've got positive 4x, and we've got positive 2x. So why can I do this? Well, in the previous lesson, we said they're just tiles. You're just moving them around. So as long as they keep the same symbol, positive or negative, you can rearrange the order. So back to the right side. We've slashed out 3 negative x squareds and 3 positive x squareds. What are we left with? So if we draw it, let's actually draw it with black here. We're left with one of these guys, and then we've got 6 of these. Okay. And if we write that algebraically, we've got x squared and positive 6x. Well, if you notice, if you just add up the coefficients here, negative 3 and plus 4, positive 4, that gives you positive 1x squared. And then the 2x and the 4x, that gives me 6x. They're both positive, so just add up the coefficients. So when adding polynomials symbolically, add the coefficients. It's just telling you the amount of stuff you have there. So if you've got 2 of something and then you add another 4 of it, well, you got 6 of it. To symbolically add 2 or more polynomials, group the like terms, add the coefficients, collect like terms. So let's start off here and just figure out, well, what's the same? Let me zoom in a little bit. All right, so here's an x squared. Is there any other x squareds? Nope, nope, and nope. So there's no other x squareds, so that's just going to remain by itself first. Let's go on to the x's. So we've got 2x here, and another 2x, and another 3x, and they're all positive. That's nice. So positive 2x, positive 2x, positive 3x. And then lastly, we've got positive 3 and positive 5. Remember, I'm careful to keep my signs. Well, let's collect our like terms. We only have the 1x squared, but we've got 2x, positive 2x, and positive 3x. So positive 2x, positive 2, and positive 3 give me 7x in total. And then the positive 3 and positive 5 give me positive 8. Perfect. Let's try another one. Start off by grouping your like terms. So scan through, see what we got. All right, so we got 3n squared. Any other n squareds? Aha, a positive 4n squared. Let's keep the same sign. So positive 3n squared and positive 4n squared. Okay, and then we've got positive 7n. Any other n's? Yeah, another one, positive 5n. So keep the signs. And then the last, we got negative 4 and negative 8. So keep, negative 4 and positive 8. Keep the same signs. Now we're going to collect our like terms. So 3n squared and 4n squared. That gives me 7n squared. And then we've got 7n and 5n. That's going to be positive 12n. And then we've got negative 4 and positive 8. So that's positive 4 in total. So our simplified expression is 7n squared plus 12n plus 4. All right, we're going to get a little trickier. We got this one right here. Don't despair. We have a different letter, but let's continue with the same process and collect our like terms. So scan through. Let's start with our y squareds. So negative 4y squared. And any other y squared? So positive y squared. Any other y squareds? Does not appear to be. So let's go on to the y's. This is positive 11y. And we've got negative 2y. And what else we got here? Negative 6 and positive 14. Okay. And if we go ahead and collect like terms, we've got negative 3y squared. Those two simplified to negative 3y squared. And we've also got positive 11 and negative 2. So that's going to give me positive 9y. And then we got negative 6 and positive 14. So that simplifies to positive 8. And that is simplified. Okay, I want you to pause this video, try this one, and see if you get the same stuff. Okay, so I'm going to stop highlighting things, but hopefully you can still follow it. We've got negative 3m squared and positive 2m squared. We have negative 7m and positive 7m. And we've got positive 4, positive 10, and negative 8. All right, 3m squared and 2m squared. That gives me negative m squared. Negative 7m and positive 7m. That's a zero pair. So you don't have to write anything. They just would simplify to 0. And all the constants will simplify to positive 6. All right, pause the video, try it, check back. Okay, you might have run into a little bit of an issue. We don't have, we've got x's and y's. Well, let's do the same thing. Group the same stuff. So 4x and negative 7x and negative 3y and positive 8y. The 4x minus 7x will give me negative 3x, and the negative 3y and the positive 8y, that will give me positive 5y. So we're good to go. All right, one more, pause the video, check back, see if you've done it. So we got negative 6m, negative 3m, negative 4n, positive n, positive 6, and negative 5. And this will simplify to negative 9m, negative 3n, and positive 1. So even though we have different variables, m and n, you still group the same stuff together. All right, one more question here. Determine the perimeter in terms of x for the triangle below. So perimeter is all sides added. Okay, so the perimeter is equal to, let's start with this side, 9x squared minus 3x squared. Okay. And then we're going to add that to 5x squared plus 7x squared, or sorry, 5x plus 7x squared. And we're also going to add that to the 2x squared minus 3x. So we're going to add that to 2x squared minus 3x. And I guess I could color code that for you guys. You're welcome. Okay. All right, so let's rearrange and put all the same stuff together. So 9x squared, positive 7x squared, and positive 2x squared. Be careful to keep the same sign. Okay, don't lose any negatives along the way. I think I did something incorrectly, and I absolutely did. Hopefully you noticed that this does not have a squared on it, but I definitely did put a square on it there. So that is a big mistake because that is not a like term. So the 3x squared is what should go there, the negative 3x squared. Okay. Just double check I got all the other things correctly. 5x, 7x squared. Yep. Okay. So negative 3x squared, the positive 7x squared, and the positive 2x squared go together. And then we can also group the 9x, that's where it should go, the positive 5x, and the negative 3x together. So we also end up with 4x squared, nope, 6x squared. Okay, the negative 3, the positive 7, and the positive 2. That'll give me 6x squared. And then we also have all the variable of x is added, and that's going to give us 11x. So the total perimeter is 6x squared plus 11x.